I really want to thank everybody for coming to celebrate the life of my father, Shinya Inoué. He'd be humbled and just so happy to see everybody here at the MBL about 70 years after he first came. That's pretty amazing. Long before I was around, he was coming here, and some of you were here as well. So much of what he accomplished in his long and productive life is due to his collaborations and relationships with each of you. And I want to thank you for that, because none of this would have been possible without you. And many of you have been in my life so long that you feel like family. And getting together and seeing all these friendly, smiling faces from the decades I've been coming to Woods Hole has just opened my heart up and made these difficult times just so much more bearable. And just enjoyable to see you all here. I just can't express how much it means to me and my family that you're all here with us. So I'd like to share today a version of one of my father's favorite stories. It's obviously from my perspective, it's a little different. It's a story he used to like to tell about me, but I think it really says a lot more about him and how he was as a father and a mentor. So 36 years ago, which in itself is difficult for me to believe, I finished my freshman year of college. And I had a meltdown during my spring semester. Like a lot of freshmen, I didn't really adapt very well. I gained 40 pounds that year. I felt stupid and worthless. And basically I dropped out of most of my classes. So I was coming back to Woods Hole that summer, pretty much feeling as an 18-year-old, lost and broken and hopeless. I never really told anybody how I felt that summer, but I'm sure my father sensed that I wasn't well. However, in spite of my feelings and my failings and how much I must have disappointed him, he never criticized me or got angry. That just wasn't his way. Instead, he did something remarkable. He came to me and he said, "Teddy, Gordon Ellis thought I should buy some video processing hardware and try digital image processing." And we all know he had video cameras hooked up to his microscope, but digital was a new thing back then. He said, "There's no programs, the documentation is just a couple stapled pieces of paper, pretty minimal. Do you think you could help me with it?" And here I was, this college dropout, and he's coming to me to try to help him progress his research. So he showed me that 50-pound computer, complete with these giant 8-inch floppy drives that shook the room when they ran. At the time, I thought he was crazy. State-of-the-art at that point was like an Apple II and some of the other things. And we had this monstrous computer. I said, "Why'd you buy that?" "I can't do anything with it. All it can do is add and subtract images. What can you possibly do with that?" So rather than arguing, he handed me a book from Ken Castleman, a NASA scientist, and suggested that I read it. But there was just so much math that it overwhelmed me. I thought, I'm no NASA engineer. I'm a college dropout. But he had faith in me, so eventually I stopped complaining and started playing with the computer. Each day I do a little more, trying to program the system to do live video processing for his microscope. To complicate matters, he insisted that it had to be easy enough for him to use. He just wanted to push a button and have it improve the image. He said the computer should fade into the background, and the microscope and the live cells that the microscope held must take center stage. And then, one day, as an aside, he casually said, "I need you to finish this before you go back to college in the fall, so I can show our results at the end of the summer meetings." So by this point, it was probably July something. What do I have? 6 weeks left, and we're supposed to, from scratch, develop this digital imaging system. Impossible, I thought. It was crazy. Well, every day he'd come in to see what I'd done after I started playing with it, and he'd ask me to refine it just so. And I know many of you students and colleagues who work with him will probably understand this example. You might remember his little pseudo-color display, where he had pretty pictures and displayed in pseudo-color. He had this beautiful rainbow he displayed it in. It looked like the light coming out of a prism. He had me tweaking that damn rainbow for days until it was perfect. And he didn't even like pseudo-color images. We had to do this. We spent days. Make it a little blue, a little bluer, make the transitions a little smoother, make this more vibrant. It drove me crazy. But the funny thing is, after all that, I believe it was an exercise to teach me that I had to be far better than just good enough. He showed me that I should strive for excellence in everything, a lesson that I carry to this day. Live with integrity, do your best, never give up. He lived these words without ever speaking them. Often when he came in requesting new features, my reaction was, that's impossible. I just didn't have the background, I didn't know how they could be done. And either did he. He just knew what he wanted to get accomplished. But his response after that was classic Shinya. For a second, his smile would falter, and he'd give me that momentary look of disappointment. That tiny scowl, the pursed lips, while he thought about how to reply. Then the smile would return, and he'd just say, think about it. I'm sure you'll figure something out. In this way, he showed me that he had faith in me, which gave me the confidence to proceed, even if I didn't know how or why. When I eventually did figure it out, and most of the time I did, he was overjoyed. Fantastic, he'd say, slapping his thigh, and we'd wheel this giant computer system into the microscope room and play around with it on the Shinyascope for maybe hours, sometimes long into the night. I was learning and achieving more in those precious moments than I ever did in the classroom. We did this for the rest of the summer. And while the software slowly took form, the menu appeared on the screen, the system really did do amazing things. And with math really no more complicated than addition and subtraction, which was great, because I'm a mathematician. We started seeing real-time images of living cells that nobody had seen before. Seeing his joy and feeling his excitement made me happy. Day by day, I discovered that my own path to happiness lay in helping others achieve their goals. At the end of the summer, we gave our demo to a packed MDL auditorium, and I think many of you were present for that. We showed a glimpse of what was possible when NASA technology for exploring the universe was turned inward to the microscopic world of the cell. My father gave the lecture, and I pressed the buttons, and he wowed the crowd. At the end, I think he may have gotten a standing ovation. I'd never been so part of anything like it, nor so proud. To give you a little idea of how it felt for me, this college dropout, you remember when Steve Jobs gave that demo of the first iPhone? That's what it felt like for me. My father made me feel that I was part of something historic, and that we were changing the world. In a period of just 2 months, my father had taken me from my lowest lows to my highest levels of personal accomplishment. From college dropout to would-be entrepreneur. Working with him gave my life meaning. Without a doubt, his guidance and his love saved my life. The story captures so much of what I loved about my father. He taught me to have integrity in all things. He set seemingly impossible goals, but only because he had faith in my abilities. He pushed me to blaze my own trails. Through his gentle guidance and through his love, he helped me and so many others realize their true potentials. And as I say goodbye to him now, I know that he lives on within each of us. His spirit fills this place, and I know he will always be beside me, guiding me through all the challenges I have yet to face. Thank you so much. So a few members of my family are going to come and say some words. Chris, you want to come up? I'm old school.
Again, thanks everybody for being here today. I know his accomplishments were a result of a worldwide team effort, and he was lucky to have so many great friends around him. So my story is a real personal one about Shinya's teacher, and he was a great teacher. I didn't attend any of his classes, a few lectures, but just experienced life with him as we do with our families. The education you receive that way has no lesson learned. You just observe and learn, you reflect, and you move on. Around 1970, Shinya took his sabbatical from the University of Pennsylvania, and we moved to Northern Virginia. We stayed in a farmhouse on a pretty 900 acres farm operated by the University of Virginia. It was for agricultural research, had a beautiful arboretum, and was partly an experimental farm. The place was quite idyllic in many respects, and he needed a break from the University of Pennsylvania. Shenandoah Valley, of course, farms and ranches, friendly local folks. And one summery day, we were driving around in our old Buick station wagon. We found a small local fair, the kind where a bunch of tables are set around in the field, and they have crafts and homemade pies and a few games and things like that. And I was walking around with my brothers, and we see a table, and behind it was sitting a man, and on the table were 3 cups and a small object. And Shinya was interested, and we assumed he knew this was the old con game, shell game. And but he decided to take up the challenge, and the guy explained how to play the game, and he put his dollar on the table, and he didn't find the pea. And he tried it again, and nothing was there. Well, he kept doing it, and we thought for sure he would give up, but he was persistent, and he didn't have any kind of winning streak. He had a stubborn streak. I think we all saw that in Shinya. Well, after a while they go for this double down dare. A big pile of money sitting on one side, and you can win all your money back. And he looked at his wallet, and it was almost empty, and he just turned it, he walked away. And I asked him, Dad, did you really think you could win? And he mustered up some sincerity, and he said, Chris, I was just trying to teach you a lesson. I still don't know what that lesson was. But it seems like if you run into a tight spot in life or your experiments aren't working out, you can always fall back on that line. You're just trying to teach him a lesson.
Not a lot of people in this room know who I am, but my name is Sean. I'm the grandson of Shinya Inoué. And one of the reasons that I really wanted to speak here today is to just sort of express to you all, because you all are his friends, his colleagues, his family, that the way in which he inspired people went beyond that. So in my life, I think that Shinya has been one of the most influential people. He funded my ability to go to a decent high school, which in turn funded my ability to go to a decent college. He inspired me to pursue a doctorate in economics, which I just completed this past summer. So I'm now working at Louisiana State University as a visiting assistant. And thus far, the job has been a dream come true. Teaching is wonderful, research is wonderful, I have wonderful colleagues, and throughout this journey, I have to imagine that these are the things that, Shinya felt, and, what I saw was, at the end of his journey through life, for me viewing him as a grandfather, I saw the family that he built, and the research that he did, and the wide-reaching impacts that it could have, and that was something that I really wanted to be a part of, and I wanted to devote myself to that. And that far-reachingness, that inspiration is something that drew me to that. I have a friend who was an undergraduate friend with me, and then he went on to study more biology. He ended up in one of the summer classes here at the MBL and ended up meeting my grandfather a few years back. And he reached out to me and said, "Your grandfather is one of the most inspiring people I've ever met." So that far-reachingness, and so I talked to Grant earlier about his research and exactly what it was, and so for me personally, I appreciate all of you for coming out here, and I really just want to extend my appreciation of the work that he's done. And so if you have a story about your interactions with Shinya or the work that you've done with him, I really would like to get to know the research side of him, because I knew him as a compassionate, loving grandfather, but really appreciate all the work that you guys have done, and would really like to know about that. So thank you all for coming.
Father and husband, but he was so much more than that, obviously, to the world. And after looking at his autobiography, we recognized that it was his connection to his colleagues, his associates and friends over a lifetime that, bringing together these absolutely brilliant people, some of whom are in this room, and who was able to harness their talents in such a way as to build these incredible microscopes and systems. So it's the generations that he was able to harness and fit together to mold into the systems that he produced. So what I like to do actually here is to honor some of the people that aren't here, and going back to people like that many of you knew and cared for, people like Kenneth Cooper and Ruth Cooper. Let's see. Gordon Ellis. And it's such a big part of both his life and the MBL. Hidemi and Yuki Sato, Mel Spiegel, the St. Georgie's, several generations of St. Georgie's. And Bertha Woodward, who worked with it, and Ralph, who ran the greenhouse at Penn for so many years. And it was such an integral part of his life. And I'm sure there are others that people here will remember and honor. And lastly, I want to honor the person that really kept him going all these years and kept him fed and on the right course, and that's Sylvia Inoué, our mother. So thank you very much.
I was number 3 son, Stephen.
A couple other people I remember from Dad's life that were very important: John Fusler and Ted Salmon, who can't be with us today, and Jane, who kept his office going for pretty much his whole time in Woodsville that I remember. I just have a few things that this is a kind of a repeat from yesterday, but it really meant a lot to me. I mean, it's great seeing all of you here, and I have very fond memories of growing up and spending my summers here. You know, the Woods Hole area and the biological laboratories here are just incredible, and just such a wealth of intelligent people. It's a fabulous facility. But many of us feel that what we do with our lives may be just a drop in the ocean or insignificant. But with each and every drop, without each and every drop, there would be no ocean. Dad's life may have started out as just one drop, but throughout his long life, he had a great impact on many others, especially in this room. Dad did his best to teach, help, guide, and mentor everyone. Over the course of his life, he helped thousands of students along their own quest to make a positive difference in this world. The lessons and work ethic I learned from watching him while growing up allowed me in turn to help thousands of other people that I came in contact with. And hopefully those people will do the same. Every other person in our family has been able to share a part of Dad through their lives as well. We were very fortunate to have him with us for the time that we did. Mom and Dad had 70 great years side by side, raising our family and figuring out life together. They had their share of challenges along the way, and it is a small miracle that Mom stayed sane while raising us 5 children. I'm sorry to say that as one of the wild boys growing up, I did not make it easy on them. This life that started out as one small drop has become its own ocean of caring and sharing. Who we are today is a direct result of the life and love that he shared with all of us. Always humble and kind, right up to his last days, I could not have asked for a better father. I will always be proud to call him my dad. Mother Teresa said, "It is not how much you do in life, but how much love you put into the doing and sharing that is important." This certainly holds true for Dad, and he put a lifetime of love into our family and into his quest for understanding life.
Yeah, thank you very much, everybody, for coming from far and near to celebrate the life of Shinya Inoué and what he meant to every one of us. I especially want to thank the Inoue family for uniting us here at the MEL, which is Shinya's scientific home. Yesterday, during Shinya's private church service and burial, a few of us could witness the impact Shinya had on his immediate family through 4 generations, despite or maybe because of his enormous dedication to his professional life. In touching personal tribute, it was apparent that Shinya lives in every one of you, and I urge you to keep this memory alive and make his legacy your own. You will draw great strength from this legacy and from accepting each other in love. Shinya was a great teacher, mentor, colleague to all of us, and all of us are tasked to maintain his legacy, the scientific rigor, the personal kindness, and we each add our own ingenuity, curiosity, and inventiveness to it. Just across the street is Shinya's lab, still largely intact and familiar to many of you, and so we brought some of the artifacts here, the poster-sized micrographs that he himself prepared, sometimes in all-night sessions many years ago. Some of you will tell stories that will bring these pictures to life, the struggle they represent in identifying important biological questions, in developing the scientific tools and methods to answer the questions, and in communicating the answers most clearly and convincingly. I'm looking forward to listening to all your stories and to your tributes to a truly great scientist and humanist who brought all of humankind a little closer.
My name's Gary Borisi. I've known Shinya as a student, as a colleague, for over many years. I want to relate a few incidents, a few anecdotes from that experience. I first came to learn about Shinya through the literature. I was a student, and his work inspired my own research as a graduate student in the early mid-60s, 1960s. And it was his work that motivated me to come to Woods Hole in 1965, which was my first summer in Woods Hole. And I wasn't in the physiology course then, I was in a different course, fertilization and gamete physiology program. But I crashed the physiology lectures. And I remember a lecture then given by Shinya. And there were several remarkable features about that lecture. First of all, it wasn't inside Lily. He said it was a beautiful day, let's go outside. And so the lecture was given outside. That means there were no slides. But he did have props. And some of you may remember how he taught about birefringence, the two speeds at which light may be transmitted through material depending on the grain. The grain, he used a wooden prop, two pieces of wood cut across the grain or with the grain, and he tapped on them, and you could hear a different pitch of sound. And he conveyed so vividly by that lesson the meaning of different speeds of light propagating depending upon the medium. And that was the underlying theory behind polarized light microscopy. So that was remarkable to me. And that made me want to come back to Woods Hole. So now we'll fast forward a decade, go into the 70s, and I had the great pleasure of actually working on a project together with Shinya and Dan Kiehart, who is somewhere back here, there he is, in his lab. And now I have to segue to Chris and Teddy, because during those years, this figure, a slim figure, would emerge from a room in the hallway periodically, and that was Chris. He was always in the dark room developing prints, and I only saw him briefly when he would emerge, and then show the prints to Dad, and then go back in to develop more. So I actually didn't see much of Chris, but I just knew he existed, and these prints were the result of his work in the dark room. And then there was Teddy, who at that time was almost a baby. I think 8 or 9 or something, 10 maybe. And he wasn't working in the lab at that time, but he would come into the lab with fishing poles and dripping. And there were experiments going on in the lab, and Shinya was very kind and gentle, always kind and gentle, and coaxed Teddy to put the rods near the door so they wouldn't interfere with the experiment, and then drew him and said, come and look at this. I don't know if you remember that, but he would introduce you to some of the work that was being done right on the spot. And of course, one of Shinya's great gifts to all of us has been Teddy and imaging science, for which we're incredibly grateful. It certainly was important. It just transformed the field. I'll fast forward another, maybe several decades now, when Sally and I had the great pleasure of coming to Woods Hole, and I had the great pleasure and honor of serving as director of the MBL for 7 years. And so now my interactions with Shinya were in a different light. And here I could see his extraordinary dedication and generosity to fostering imaging science. And the MBL and all of us owe a great gratitude to Shinya and his family, whole family, for endowing position at the MBL and funding the imaging science at the MBL, and persisting through some difficult times of getting imaging supported properly. Still needs more support. During this time, Shinya received one of his many honors, the Japan Prize, and Sally and I had the great pleasure of going to Japan with him for him to receive the prize. And Sally reminded me as we were coming down in the car of something that happened when he was addressing the audience at the time of receiving the prize. He said many things, of course, about the award and the science, but then he said to the younger members of the audience, "Don't be so respectful to your elders." He was trying to teach them something. And then he turned to the organizers and some of the elders who were deciding on the Japan Prize and who were in attendance as honorary figures. And why can't you get more women into science? This individual, as everyone has said so far, is a pioneering figure in science, the pioneering figure of study of living cells, a great teacher, a great parent and friend, a very great benefactor, and mischievous, and provocateur at times as well. So I just want to close with a poor haiku for Shinya. And here's my poor haiku. Mysteries of life. Dynamics of living cells. Imaging unblocked.
Hi everyone, thank you all for coming. I'm Jane Layton MacNeil. I've never followed a director before. I feel a little intimidated, but I'll do my best. I met Dr. Inoué 40 years ago when I first came to the MBL. I was working in the admissions office with Mort Mazer. Many of you might remember him. He introduced me to Dr. Inoué and told me I would be providing him with secretarial services for his first AQLM course. Of course, I couldn't pronounce the words in AQLM, so I was glad they kept abbreviating it. This was before there was a computer on every desk. And Dr. Inoué kept asking me to retype the list of faculty, students, and vendors who would be participating on my IBM Selectric typewriter. Each time a new name and address was added. He wanted to be certain this stayed in alphabetical order. I realize now that this was just practice for how many drafts he would ask me to type of his first edition of video microscopy. The list of qualities I could use to describe him are endless. They include words, in alphabetical order, of course, like brilliant, diligent, diplomatic, generous, honest, humble, kind, precise, respectful, sincere, and virtuous. I had another word in there that I took out because I was afraid to say it, but I can't. I want to have as much integrity as he did. So the word is demanding. I don't need to tell you what a unique and special person he was, because if you are in this room today, you already know that just by having been in his presence. What I do want to tell you about are some of my personal recollections from working as his executive assistant for so many years that I think exemplify many of his amazing qualities. He never asked me to get him a cup of coffee or make him a cup of tea. But he did often ask me to go to the food buoy and get him his lunch. Honestly, I am surprised that he lived to be 98 years old on his diet of egg salad sandwiches on white bread with a bag of potato chips. I admired his strong work ethic. We would get together on Fridays and plan his schedule for the upcoming week. He followed it precisely, even when it called for him to be writing a grant or reviewing someone else's. And he never said, "I don't feel like doing that right now." He also never gossiped. But I do remember a conversation we had about a young colleague who he was concerned about because this colleague wouldn't sleep on a cot overnight in the lab. Dr. Inoué seemed to think that no scientist could be successful without doing so, which is why he always had a large reclining chair in the middle of his office. He was amazingly generous to me and to my husband, Dan. When he and Sylvia bought solar panels for their house on Shore Street, he thought they were such a good idea that he wanted to buy some for our house as well. I was so appreciative, but at the time our furnace wasn't working very well, so he paid to replace our furnace instead. He never raised his voice in front of me in the entire time I knew him. We did argue, however, about two things. The first was his pet peeve about why the MPL kept increasing their administrative staff when they weren't bringing in any more scientists. After all, he'd say, Homer Smith and Florence Butts ran this place for years without any extra help, so why does MPL need it now? The second argument was my pet peeve, when he would attempt to correct my grammar or punctuation. I would tell him he might have gone to Princeton to get his PhD in biological sciences, but I had gone to Holyoke Community College to get my associate's degree in secretarial science, and I knew best. Diplomatically conceived. Dr. Inoué was definitely a night owl, and I wasn't. He would come to work just before lunchtime, while I would have started at 8 a.m. His preferred style of working with me, even after we began using personal computers, was to dictate letters. He would call me into his office in the early afternoon, and I would sit with pen in hand while he composed his thoughts. As I waited for his next sentence, I would often fall asleep. When this happened, he simply cleared his throat several times to rouse me. With his extraordinary kindness, he never said a word to me about it. It happened a lot. He never threw anything away. He saved every letter and every gift he ever received. He also saved every yogurt container that he ever ate out of. He used to tell me he was certain they could serve a useful purpose. After all, this is the man who used a discarded machine gun base to support his first microscope. And while there may have been a use for everything he saved, it certainly made finding something among the piles in his office extremely difficult. To this day, we were never able to find a napkin he had written on during a conversation he had with Gordon Ellis, which he said had a very important formula on it. I'm afraid it may have been one of those items that I looked at and said, a bar napkin? We can't possibly need to save this. It was an honor and pleasure to serve him for as many years as I did, but I know Dr. Inoué would think me remiss if I did not mention two other loyal employees who served him well, Bertha Woodward and Bob Knudsen. They both began working with Dr. Inoué when he was at Dartmouth, and then moved with him when he went to Penn, and finally followed him to Woods Hole. I definitely understand their dedication and devotion to him. He earned theirs and mine many times over. I want to thank Sylvia for treating me like a member of the family, and for always making room for me in her home when I came to work there. I know that wasn't always easy, but she always made a space for me. I want to thank the Inoue children, all 5 of you, Heather, John, Chris, Stephen, and Ted for putting together this memorial service and for letting me speak here today. More importantly, I'd like to thank them for so generously sharing their father's time with me. I wish we could have all had much more of it.
I'm Kip Sluder, a former graduate student in Shinya's group, and simply want to pay tribute to the time, effort, and care that Shinya took in training us. And as a new graduate student, particularly in my case, I came from a small liberal arts college up in Vermont with very classical training in biology, comparative anatomy, classic embryology, not much modern biology. But anyway, so for a beginning graduate student, Shinya was a terror. He really paid attention to us and was on our case pretty much all the time. But when I first met him, I went to his office for an interview. He had a wonderful way of leading you down the garden path with a number of simple questions. And then, once he got you well down the garden path, snap the trap shut. And ask you a very fundamental, profound, and difficult question. He did this to me on the first time I met him. I was absolutely flattened. And it had to do with why DNA will base pair to itself with hydrogen bond. Why does it just hydrogen bond to the water all around it? Well, I didn't have the presence of mind to use the traditional academic hand way, say, well, of course, it's easy, it's more favorable. And I didn't have the presence of mind to ask him what his answer was. But anyway, so another avenue for training us, well, first of all, I would say that Shinya didn't do much training in the laboratory arts and the methodology. Demi Sato did a beautiful job of that with us, teaching us how to make preparations, how to handle marine organisms and whatnot. Shinya was more interested in developing our intellects and developing the way in which we communicated, the way in which we developed concepts and defended or planned and defended our experimental approaches. One of the avenues for this was our weekly meetings where we present stuff, we discuss issues. And as a graduate student, you were always, Dan Kiehart smiling here, he knows, we were always under very close scrutiny. And I remember one time when Dan was showing one of his latest and greatest bits of work, and I made the mistake of asking an ill-conceived question. Within a millisecond, Shinya had me up at the board defending my question. I would add, not very successfully. But anyway, through experiences such as this, painful experiences such as this, he taught us to be rigorous, to think issues through completely, to think ahead, and have well-considered points of view and an understanding of the concepts involved. And above all, we learned to keep our mouths shut, unless we were on very solid ground. I'll close with one more anecdote, and this has to do with, certainly for some graduate students, Ted Salmon in particular, if once a student, always a student of Shinya's. And this goes back to the 1990s when Dave Wolf and I were running the AQLM course, which is a course started by Shinya. And we normally would have Shinya do a wrap-up lecture at the end. And this was a wonderful lecture reviewing several decades of Shinya's work, about a 2-hour performance with Bob Knudsen doing the audio visuals, a lenticular screen and a projector, and but anyway, but the rest of the course, Shinya wouldn't show up at all, with one exception. And that was the day that Ted Salmon gave his lecture on polarized light and polarization microscopy. And every year when he was in good health, on that day alone, Shinya would come in and sit in the back. Now, I don't think he was looking to learn anything about polarized light. So I'll leave it to you to think about what else he might have been doing. But anyway, after being a PI and having my own lab, I have now an appreciation for the time and care and effort he put in to training us. And it certainly has served us all very well. Thank you.
Switch your order a little bit here. Lara, since we had a St. Gyorgyi mention here, here's an official St. Gyorgyi family. We actually have 3 today who are speaking. We're lucky enough to have that.
Hi, so I am Lara Szent-Gyorgyi. My father was Joe Szent-Gyorgyi, Andrew or Julia's brother, and my mother was Gwen, formerly Gwen Pryor. So I just want to talk a little bit about the friendship. It's really just an anecdote, I think, that kind of evokes the friendship. So I was born in Woods Hole, and when I was just about 2 years old, Tei Hayashi became the chairman of the Department of Biology at the Illinois Institute of Technology. And he offered my father a job, and so my parents packed their bags and off we went to Chicago. So my experience with Woods Hole is really our visits, our annual visits. We would come back every summer and we would see dear friends and family. And my adored older cousin David was here, and he would be playing, or he and Teddy would be geeking out on computers. And very generously would let me kind of hang out with them and play ping pong with me in the basement. And I remember sort of every once in a while seeing Shinya. And you know, all of the people that we saw, they were so important to my parents. And over the year, when we were in Chicago, they would talk about Woods Hole and all of their friends. And one of the people that they clearly held in high regard and esteem was Shinya. And he was just someone they spoke of very lovingly. So they always considered Woods Hole their home, and they clearly wanted to retire here. So when I was in middle school, they bought a house in Woods Hole. And when I graduated from college, they moved out here, and they lived here for 25 years in their very small, little, modest house, very happily. They loved it here. I know that, as I said, they held Shinya in very high regard. They would, my mother would periodically reach out to Shinya for advice. I think that she actually helped my mother get a job with Ray Stevens here when she came back. And I believe that actually Shinya was the last person she worked for. That was her last job. So what I really wanted to say was, people have talked about how innovative and forward-thinking Shinya was in science. And I just have a little anecdote about how that was true in other aspects of life as well. So my parents, after they bought a house in Woods Hole, and I think they sort of realized what that process was and what the cost was, they would relay the story of how when they were first married in the late 60s, Shinya really encouraged them and tried to convince them to buy land on Martha's Vineyard. And this was back when Martha's Vineyard was a lot different. It wasn't as popular, and it wasn't really the destination that it is now. And, you know, by the time my parents were telling the story, it was clear that that would have been an excellent investment. And I asked them, you know, why didn't you do that? And they said, well, back then, our thought was, why would we do that? And they always acknowledged that they should have taken his advice.
So, Ted, thank you very much for this opportunity. As you probably already heard, I started life in Shinya's lab as a graduate student, but before then, I was an undergraduate, and that posed a problem. I was a work-study student in his lab, did some experiments my senior year. I was desperately trying to finish Penn in 3 years. I was taking a pretty rigorous load of courses, so I couldn't take an independent study. But Shinya was very generous. He said, look, after you graduate, would you like to work with me over the summer in Woods Hole? Before you start graduate school in the fall. And I said, sure. He said, well, when are you going to graduate? I said, well, May 8th. He said, good, I'll see you on May 9th. And so this idea that I had that maybe I'd spend a week at home or something like that for finals and graduation, that was off the table. You've heard many things that describe Shinya: integrity, innovative. All these things are absolutely true. Perfectionist hasn't come up, but they're all implied by many of these things. And I really learned about perfectionism when I tried to write a PhD thesis with him. And in fact, I was such a hopeless case that he assigned, or actually helped pay for Nancy Salmon, my older brother Ted Salmon's wife, to usher this thesis from a ridiculous draft into something that was even vaguely comprehensible. And the rigor that Nancy helped me develop has really worked through. And years ago, my own biological father died, and I was told by a theologian at Duke, one of my senior mentors, that I would think about my father every day. And it's true that I actually think about my biological father just about every day. But I think about Shinya even more frequently, my scientific father. And that comes from every time a graduate student sets a slide on a table without a little inverted cap under it so that it can collect dust. Tries to be up the wall. I think about Shinya then. I think about Shinya when I use Valip to seal my slides. I think about something that everybody said here about life on living cells. So every time one of my graduate students wants to stain an embryo with antibodies, it gives me the heebie-jeebies. How do you know what's true and what's not? I know that when I work on live cells, they either made it or they didn't, right? And if the end is that it divides, it's great. If it turns into a fly at the end or some later stage of fly development, I'm a happy camper. As soon as I put fix on it, I don't have any idea what's going on. And so that was something that was really important. I will tell you one interesting anecdote about rigor in writing. So when I was a senior graduate student, Ted was in the lab for whatever reason. He had graduated several years ago. He was my mentor that summer because Shinya was away. And Shinya came back for a short period of time. And Ted had clued me into the fact that you really want to get in early because Shinya's idea of dawn is around 9 or 10 o'clock. And if you can be there by 7, you can have an experiment going. And no matter what happens, he respects that you have an experiment going and he's not going to interrupt. He'll take time later in the day to interrupt, but why have an experiment? So anyway, I started out at 7 o'clock, and around 10 o'clock, I desperately needed a snack. So I went down to the food booth. And again, this is a story about rigor in expression. So Shinya's there, and he's peering at a small can of orange juice. They used to sell these, I don't even know if they do, but they were about 4 or 6 ounces worth of orange juice. And he was looking very quizzically, and he couldn't decide what he was going to buy for breakfast. And I finally said, Shinya, you shouldn't buy that. They're terrible. Buy a quart. And Shinya looks at me and says, if they're terrible, why would I want a whole quart?
I was born and raised in Woods Hole. I don't think there are very many in this room who can claim that. I also came to Woods Hole 1 month before Shinya did, thanks to my mother. And probably only one of the few people to talk here who didn't really interact that much with Shinya, because my relationship with Shinya was as a family friend and in Woods Hole, but primarily when my father was at Dartmouth. But the community and the genesis of creative science by people such as Shinya and my father are a real theme. And both of them came from war-torn countries on the other side and had to make do with what they had here in this country.
And the way that they accomplish this, by dint of many personal characteristics, but simply faith in what they do and faith in growing what they do through interactions with other colleagues. So one of the common threads in Woods Hole is that everybody knows everybody, and the fact that you know everybody goes with you wherever you go, okay? And if you read Shinya's autobiography, and I've only read half of it so far, this is very obvious. The people that he did science with were intimately connected to him, okay? In my case, I came from a scientific background and didn't go into science till after the Vietnam War. My education was war-torn also. And I wouldn't touch what my father did, or my great-uncle, who also studied muscle with. I wouldn't touch that with a 20-foot pole, okay? And so I went into science and decided I'd be a molecular biologist, a yeast molecular biologist. But right now, I am a soft money scientist after a 30-year motley career. I'm at Carnegie Mellon University in the Molecular Biosensor Imaging Center. So, although I don't do polarized microscopy, and birefringence is not one of the things that I focus on, the long arm of Shinya Inoué is present, okay? Action at a distance, action at career distance. So, the kind of relationships that all of you had to Shinya are not only valuable to you, but are an example of how science should be done. And even if you don't have a personal connection to Shinya, the consequences of what was done by Shinya and his friends here are very real and very obvious to people at a distance. So obviously, Shinya had a profound influence on my family by virtue of his day-to-day interactions with my father. He hired my father to go to Dartmouth, where I had perhaps the 3 or 4 best years of my life. Hanover was a wonderful place. And I went to high school with Heather Hill, Shinya's stepdaughter, and it was a tremendous time. And I know that my parents would have had some great stories to tell. I just have the downstream benefits of them having known Shinya. So thank you very much.
So I first knew Shinya when I was a student here in the physiology course in 1962. And the other faculty in the course, all of them admired Shinya and repeatedly said what a great scientist he was, and so that began my admiring Shinya. Then a few years later, I became a postdoctoral fellow with Richard Keynes in England, and Keynes had earlier measured light scattering signals from nerves when they were active, and the year before I came, he got a new piece of apparatus that made these measurements much more sensitive and much faster. So I worked on measuring light scattering and birefringence from nerves. And I came back to Woods Hole, and sure enough, I met Bob Barlow and Shinya, and they were trying to do exactly the same experiment. And right away, they were very supportive and kind to me. And they actually remained supportive and kind to me for the rest of their lives.
I got the letter from Ted about Shinya's death, he said that Shinya had valued my friendship. And that made me feel regret that I didn't often enough and publicly enough tell Shinya how much I admired him. But since he valued my friendship, that meant that he knew that I admired him, and so that was good. Everybody is kind of aware that Shinya was an exceptional scientist, and that's actually unusual among scientists. Everybody's aware of that too. In addition, he was exceptional in being kind to everyone. So he had both of these qualities, which made him a very special person. Finally, in the conservative Jewish tradition, they say that a person who has died lives on in the hearts and minds of the people who loved and cared for him. And that's about Shinya. Thank you.
So I'm kind of a last comer to meet with Shinya when I was studying the force and polarization imaging in Hokkaido University. I found the ad that the MBL was trying to find someone who was interested in coming to the MBL, and I was a faculty member of Hokkaido University, and but I decided to jump into this society, and the reason why is I was one of the admirer of Shinya Inoué, and somehow I tried to learn from him how I can learn the mechanism of light through the microscope. And I came here, and he showed me the magic of the MBL as an experience of my own. So I came here without having any strong connection with the academic society or the community of the biology in the United States. And I came here, and I found a lot of great collaborators and mentors, teachers, and now I found the magic of the MBL is true, and so I think I came back to Japan last June, thinking of I have many reasons to go back to Japan, but I came back here, and I really want to keep the magic of the MBL forever for the younger scientists who maybe come from abroad or from the United States, wherever from worldwide, to learn something new, and to find great collaborators here, great friend here. So that's the magic of the MBL. So I would like to try keeping this environment from Japan. Thank you.
My name is Tim Mitchell. I wasn't intending to speak. I'm not a student of Shinya's. I'm a student by second degree because I feel I'm a student of Ted Salmon, who's just a wonderful man. I so wish Ted was here. He's certainly here in spirit, but I did interact with Shinya at Woods Hole. But if you'll forgive me, I wanted to do one thing. This is an event about Shinya as a father, a mentor, a human being, and it's been so moving, and I knew that side of him a little bit. I wish I'd known more, but I did want to make just a very quick word about his brilliant discovery as a scientist. And I hope that the non-scientists in the room may roll their eyes, but I think it's kind of easy to explain. So let me presage it by saying most scientists like me go through life and we add incrementally here, and we publish, we train some students, and science goes forward. But a very, very small number of scientists really come up with an idea that really changes things and lives forever. And Shinya was one of those. He's one of the, absolutely one of the greats. He's, in my world of cell motility and cell organization, he's up there with Cohen and people. I think he doesn't get that kind of credit because, it's perhaps a smaller world. But let me just try and explain what I see as Shinya's brilliant contribution to science, because it's not very difficult to explain, I think. And let me say, when we think about living things, we think about them reproducing, but we also think about them moving, especially animals. We are animals, we move. There's been these lovely movies that Shinya took with his microscope, and you can see things moving. And so the study of how things move in biology, cell motility, is really the science Shinya and many of the other great scientists in this room are associated with. And there are kind of two ideas for how things move in animals. And Shinya is responsible for one. It's the less famous, but it's actually the more prevalent. So there's one idea about how things move comes from Huxley and Szent-Gyorgyi and many others, and explains how our muscles move. So when you move your arm like this, what's going on inside your arm there are these filaments that are quite stable and they slide against each other. The filaments don't grow and shrink, they just slide, and there's a motor that powers the sliding called myosin. And that idea, coming from Huxley and Szent-Gyorgyi and others, was hugely influential in the science of cell motility. And everybody thought basically all movement in cells would be that way, I think, in the 1960s, 70s. Except actually one man, and that was Shinya Inoué and his students. Shinya had a different idea about how things moved in biology, and I don't know when he first came up with these ideas. I never really got a chance to discuss it. It's from reading his publications, but I think it would have started in the early 50s when he was looking at mitotic spindles with polarization microscopy and grew, and he published a very famous article with Sato in 1977, cell motility labile association with macromolecules. And his idea for how things move is a little harder to explain because it's not so familiar from large-scale things, like trucks or trains or anything. But Shinya's idea is things could move in biology by having a filament that grew by adding subunits, and that could push, and the same filaments could actually pull by shrinking, the subunit shrinking. So there's the only macroscopic analogy I can come up with, if you don't do the right things with your plumbing in your Woods Hole house and it freezes in the winter, the pipes could explode, and that's because the ice crystals, the growth of the ice crystals is powerful enough to actually burst a pipe. And Shinya realized, starting, I think, really in the 1950s, and then culminating in the 1980s with work of people in this room and Ted Salmon, who I wish was in this room, that's, for example, how chromosomes are moved in mitosis, all the movement inside bacteria of that nature. And that idea of moving things in biology by growing and shrinking protein filaments is really Shinya's idea. It was not a popular idea. It took many years and many, not until these things were sort of instantiated at the molecular level in the 1980s and 90s by people like Gary Morrissey later did it really become mainstream. But it's a simple idea, and I wanted to try and explain it because it's really one of the great contributions to all biology of any time.
I'm David Szent-Gyorgyi, Woods Hole brat, one of the sons of Eve and Andrew, eventually employee Universal Imaging, and supporter of all things in life science. I was born to a life science family, which treasures stories of our lives in science and around it, and our lives in Woods Hole. So, if you mention broiled fish, dinner, the name Hugh Huxley, and my father, you're actually touching upon an inheritance within my family that has been retold countless times. But I have a story to tell you about Shinya. My parents shared with Shinya Inoué an appreciation for science as a long-term enterprise, for the need to move entire fields within science forward, and the desire to help others add to the store of knowledge that was shared in common. And in his autobiography, Shinya writes of becoming friends with my mother and father in 1949. They were young scientists in a Woods Hole community where science ran all the time. It never stopped. My father was early in his life's work on the regulation of muscle, and he obtained birefringent crystals of light maromyosin in 1952. He needed photomicrographs of this result, and he knew that Shinya was both an expert at polarized light microscopy and most generous with that expertise and with his time. So my father asked Shinya's help in capturing these photomicrographs, only to receive a rather memorable answer. "I would love to help, but I have a constraint. I'm to be married tomorrow." I don't know which characteristic of my father is more striking. The sense that science calls us to help our fellow, or the acceptance of long hours in the lab. My father knew his manners, and he could not expect Shinya's help under the circumstances. Except that in befriending Shinya, my father had found a fellow, one who also possessed these characteristics. I'm pleased to note that Shinya did not miss his wedding, as the presence of his family here shows. My mother and father were guests at the wedding on the 18th of July in 1952. But I must also share my father's report that he and his friend Shinya did stay late in the lab that day. The photomicrograph appears in a paper that my father submitted with proper credit to Shinya for taking it on the 1st of August of that year.
My name is Phong Tran. I'm visiting from the University of Pennsylvania, and for 8 summers I worked here at the MBL from 1994 to 2001 in the Dynamic and Living Cell program, which was run by Shinya, as well as his collaborators Rudolf and Michael Schriebach. And so I trained for my PhD with a man named Ted Salmon, who trained for his PhD with Shinya Inoué. So in some way, I'm a scientific grandchild. And the work that Shinya started with the spindle and was continued by Ted Salmon, and now continue with my own lab at the University of Pennsylvania on spindle dynamics. So during those summers, in the early sets of those summers, I worked with Rudolf Oldenbourg, and in the later sets of the summers, toward the later years, I would work with Shinya directly. And so there's lots of nice memories of that, and I'll just share briefly one, which is Shinya has finished organizing his monster of a microscope, a Shinyascope, and for polarized light, fluorescent polarized light, that he was very proud and wanted to show off and wanted to do something with it. So Shinya, imagine Shinya standing here, Ted Salmon, his former student, standing here, and I, Ted Salmon's student, standing here. So Shinya was explaining the scope, and he turned over to Ted and said, "Could you go make me a slide so that I can look at it in a microscope?" So then Ted turned over and looked at me and said, "Could you go make me a slide so that Shinya can look at it in a microscope?" And I turned over, and there was no one else. So at that moment, I thought, okay, I'm inspired. We should one day, I want my own student to tell to go make me a slide. But on a more serious note, in many parts of those many summers, I never understood why Shinya was such a kind person to me, knowing that I was a graduate student, which we at the time had modest means in terms of coming to Woods Hole from the institution, home institution in Chapel Hill. Every summer that I come, he would say, "You can stay at Harbor Hill." And I didn't know what that meant at the time, but it turns out Harbor Hill is a 3-bedroom cottage, walking distance from the lab, and I would have my complete privacy in this house for all the summers that I stayed. I appreciate it more and more as the day go by, his generosity toward me, and his legacy of what he studied and now is doing now. I cried when I heard the news, but as you all know, he was such a generous man, and this is how he has helped me in my career and who I am now. So I thank the family for this kind invitation, and I love him very much.
Gene Sanger and I were graduate students at Dartmouth Medical School, the new graduate program at Dartmouth. I was in the first class of 5. There were 4 males, 1 female. And in the second class, Gene's class, there were 4 females, 1 male. It's not that Gene and I met them. We actually had been dating 2 years earlier. Dartmouth was a great place to be a graduate student. And Ray Stevens came, he had taken the physiology course in the summer of '63. And I went to Dartmouth because I loved muscle. And I knew that I wanted to work with a new faculty member there, Lara Szent-Gyorgyi. And in my first summer, after finishing that, Andrew sent me to Woods Hole. I was to learn electron microscopy. And I was, one of my 2 heroes in science, Shinya Inoué, and the other one is Lara Szent-Gyorgyi. And Lara Szent-Gyorgyi charged me that summer was attend all the physiology lectures, dealt with Philpott, will train you in electron microscopy. I want you to come back, and your work has to be as good as my another hero, and that is Hugh Huxley. And I had met Hugh several times because Andrew and Hugh were very good friends. Jean was a chemistry major. I had met her in New York, and she wanted to go to another school to do chemistry. And in that first year, I said, Jean, you have got to come to Dartmouth. This is a fantastic program. They have great people here. And so Jean did come. And that advanced things, and eventually we were going to get married in the fall of '64. And Shinya, knowing about this, decided, well, let me go just back 1 year. When Ray joined, Shinya is a fantastic teacher. He set up a course called First Principles of Optics, and the 3 students in the course were Ray Stevens, Gene McGilvery, and myself. We met from 8 to 10, Monday, Wednesday, Friday. And Shinya was in the lab with us for 3 hours. And our job was, we'd label proteins as a pre-column. So the way we got, we put the dye on BSA, and we did extensive dialysis, and then we would inject. Now, the other thing Shinya did for us when he started that course, he made each one of us buy a copy of The Cell in Development and Heredity by E.B. Wilson. And he said, all the great ideas about cells are in that book. And it's about, oh God, my memory is that it was like 500 or 600 pages, very thin. I bought that copy, and we were expected to read that. He said, there are people who did these experiments, you have the background once you read this, and now you have to bring, now this is 1963, 64, modern tools to understand these problems. And so that course, First Principles in Optics, was fantastic. We read all of Shinya's papers, other original papers. Kenneth Cooper came in and showed us slides that E.B. Wilson had used, and the figures were drawn from that. So Kenneth Cooper had a contact with E.B. Wilson. It was, just incredible. Now, the other thing that Shinya did came the fall. He decided that even though we were more like first and second year students, we had to go to the cell biology course. Not the cell biology course, the cell biology meeting. So in 1964, we went to our first cell biology meeting, and what Shinya would do was incredible. He would introduce us to the leading cell biologists, and he'd say, these are going to be future leaders in the field. And so we met Keith Porter, we met George Pilati, and it was just amazing. I just felt like he knew everybody. I had to just backtrack a little bit. When we were in that course, in reading his papers, and here it's between 8 and 10, he said, what did you think about this 1959 paper I summarized on the thermodynamics of this? And we all thought it was a good paper. I had to tell you, I just remember the diagram, losing the structure of water around that, and that seemed to drive the formation of the spindle. And then he said, Joe, didn't you notice that there was a mistake in my mathematics? And I said, Shinya? I didn't say Shinya at the time, it's Dr. Inoué. Dr. Inoué, I just can't imagine that you made a mistake. And he said, don't trust authority, just question everything. So I have to tell you, he was really fantastic. Now, he influences continue into the present. When I became, for a 5-year term at Penn, the head of the cell biology program, I noticed that we hadn't sent anybody to the physiology course in 10 years. I went to Lee Peachy and I said, Lee, we've got to have Penn graduate students taking the physiology course. This is terrible that we don't have them going. So I said, if I pick out the two and convince them and their PIs, who often were very selfish, unlike Shinya, then would you pay the other half of their expenses? And he says, yes. Well, one of the first ones who went was Clara Bordeman Storer. And she related how she thought I was just, I said, you have to apply for this course. And so every year for my 5 years, we got 10 people into that course, because that was the influence of Shinya. Also, I have to tell you, once I was at Penn, as a graduate student, if I wanted to borrow a piece of equipment to look at some muscle experiments, Bertha would make me sign away my life. Now, Shinya is across the little biology pond. Gene and I are in the anatomy department, and I'd have to go over to Shinya's lab and borrow an objective, and I'd say, Bertha, Dr. Inoué is okay my use of the 63 exercise plan format. And she would say, oh yes, here. I said, Bertha, don't you want me to sign for this? She said, no, now you're a doctor. I couldn't believe it, there was such a change. I mean, the people who were mentioned, when I you worked for the Hughes Aircraft Company at one point. We had one of the aircraft boxes, which had 3 or 4 frame buffers. And we paid $40,000 for that. And I had signed with my life at NIH. They were willing to give Gene and myself all this money but $40,000 for this item. And they said, I said, look, in order to do my experiments, we need this. And they said, well, do you know Shinya Inoué? And I said, yes, I do know Shinya. Do you know Gordon Ellis? And I said, yes, I do know Gordon Ellis. These guys trained me. And I said, well, if you can get a letter from them. So I went over, Shinya happened to be away, and I told Gordon about the facility. I said, well, they want him. And he said, well, Joe, I need a little time. So I went back thinking, we're not going to hear from Gordon in about a week. And I thought Shinya would be back by then. 1 hour later, Gordon gives me a 3-page letter. I telex it to NIH and it says,
Gene and Joe wanted to do experiments. They didn't want to reinvent what's already on the market. And so the 40,000 came, we both signed a letter saying we will use it to buy this box. 4 years later, we went from 3 or 4 video things to Metamorph. And now we have 1,000 frames, and we could put these on the OMDR and make video. So we were lucky enough, because being connected with Shinya Inoué and Ted Inoué, that we were a beta site. So we had a problem in some of the imaging of our muscle or dividing cells. We just called up Ted and said, hey, we'd like to do this. And so he solved that, and it was just so exciting. Once I left Penn to sort of do something new, one of the things I made sure, because of the continuing influence of Shinya Inoué, I made sure that there was a pot of money that I would get as chair, that I would be sending students to cell biology meetings or encouraging them to take courses. So in my very first meeting, I said I want people applying for the courses here. I want all of our students to be going to the cell biology meeting. I remember Shinya sending Gina and myself and Ray Stevens to attend that ASB. That meeting was so important in our training. I wanted our first, our second, and our third year. So we have about, in the department, about 20 graduate students, and we send a cohort. And I always think of them, they are inheriting what Shinya gave us, a love of cell biology. I have to say we don't require our students to read the E.B. Wilson book, because we do require them to read Shinya's love of working with live cells. Gene and I published what we thought was an important paper in 1980 about the polarity of actin and primitive myosins and the cleavage from the stress fibers. And Shinya pulled us apart after the paper. We were very proud of that paper. We were the only 2 authors. Shinya said to us, you know, Gene and Joe, I trained you to work with live cells, not do this EM. Start thinking about live cells again. So we did. I went up to Berlin to learn microinjection, and Gene took Shinya's video course in 1982, I think it was. She was in the 2nd class. When we came back, we did microinjection of fluorescently tagged proteins into live cells using video microscopy. So Shinya really taught us love NBL, love live cells. So here's just continues to be an important interest in, an effect on our life. And we'll never forget him. He was just an incredible mentor. Teddy, I don't think you realize that when you were born, that the party for you in the basement, and Gene and I were present, and I believe you might have been a month or 2 older at that time. So we were with Shinya at Dartmouth. There was a tragic mistake the way Dartmouth blew up. We won't go into that now, but then he went to Penn, and Gene and I went to Penn. And so we interacted with him again. So we were there in the 60s, the 70s, and the 80s. And we continued to see him. When I would see Sylvia every year, she greets me with the same thing. When I passed my prelim, Shinya had a party for it at his house, and I learned why I didn't like lobster. When I went there, Gene, I said, oh my God, it's serving lobster. And I just said, oh, I don't like it. Gene said, you have to eat it. This party is for you. I found out why I don't like it. I was terribly allergic. I was sick as anything. Within about 15 or 20 minutes, I'd be taken to the hospital. Every summer, excuse me. Every summer, when I would see Sylvia, she always greeted me with the same greeting. Joe, have you had any lobster? So anyway, Shinya, we have your love of science. It was always infectious. We admire you. I do remember the one time, there were 2 fantastic lectures in my life, Shinya Inoué and Hugh Huxley. And Ray Stevens and Gene and I were disrespectful in that we always looked at Shinya Inoué giving lectures. We said, well, another great lecturer. But he had to, one time, when he wasn't so good, they had this new Kellogg auditorium at Dartmouth, and he was very nervous. And I asked him, Shinya, you're so good at giving these lectures, why are you so nervous? And he said, Joe, I always feel if I give a bad lecture somewhere else, I can always come home. If I give a bad lecture here, this is where I live and work. Again, it was always up to Inoue. I don't think you'll give a bad lecture, and he didn't. I always called him Dr. Inoue. We were sitting together at a board conference, and I'm saying Dr. Inoue, and he said to me, Joe, we have known each other for 20 years. You should be calling me Shinya. And all I remember saying was, yes, Doctor. I had to tell you, thereafter I called him Shinya, but I was a child of the 60s and things were different. Anyway,
the first is to thank all of you for being here and for all the roles that all of you have played in the sciences and in this community. Work to this. When I received the note on Shinya's passing and on this gathering from Ted, I went through a lot of emotional review of what has gone on and put together a short piece. I'll share some tidbits from it. My respect and regard for Shinya is similar to all of us here. Mentor, scientist, colleague, friend, who could see in people their capabilities and help them find a way to be able to develop them. It's unique, truly unique. I first encountered Shinya in 1964 as a freshman in high school biology. I was assigned a paper from Scientific American to present to the class called How Cells Move. And in that paper, I learned about muscle physiology and structure, cell division, and cross-reference to a paper by a fellow named Dan Mazia. Names of Shinya Inoué and Huxley and Szent-Gyorgyi and Ray Stevens and others all were intertwined in these stories. And I gave my presentation and explained to the class the sliding filament theory and the movement of chromosomes and this notion that you would have subunits that were disorganized that somehow became organized into what we would refer to as an anisotropic structure. And then that change in that would affect cell shape and motility. This captured my imagination and opened what I refer to as my mind's eye. Okay? And many people here have had the same type of experience of things that Shinya did and ways in which he would work with us and guide us. The biology teacher responded, "This is all wrong." And I said, but these scientists have used these methods of X-ray diffraction and polarized light and the electron microscope. And I tried to explain how these different methods worked. I mean, I'm a freshman in high school. What do? I went to the Chicago Public Library and I read as much as I could get. And she goes, That doesn't. You're not getting an A. All of this is wrong. The polarized light microscope is artifact, and the use of the transmission electron microscope in biology is nothing but a passing fad. Undeterred. So when I went for my undergraduate degree at Illinois Institute of Technology, and I started out in metallurgical engineering. And one of the reasons was because the tools that they used every day were X-ray diffraction, polarized light, and electron microscopy. And I was still fascinated with this biology stuff. Well, the engineers this is before biomedical engineering, would not let me take biology classes as electives. But the biologist said, wait. You say you want to transfer from engineering to biology, and you want to take thermodynamics, physical chemistry, and semiconductors as electives instead of sociology. I said, yes. He said, we've never had this before. Fine. They signed, I was a biologist. In a class, I proposed, not only answered the final exam, but proposed experiments to test the hypothesis I put forward. All of this would have been very familiar to Shinya. And I needed a job for the summer. And I asked the prof, and he said, well, you know, there are no jobs, but how would you like to do the experiments? And one day we're sitting doing the experiments, reassembling contractile units, and the professor looks at me and he said, how'd you get started in all this? And I tell him about the high school business. He said, well, what article is this? I said, How Cells Move, by Professor Tei Hayashi. And that was Tei. Our paths crossed. Okay. As a postdoc, I figured out how to isolate a mitotic apparatus that could also regulate calcium concentration. And at the time, this was kind of considered fantasy. It was the dark side of mitosis, calcium. Membranes were the dirt in the preparation. Well, through suggestions, I took the first AQLM course. Now I got to meet, as a mentor, Shinya, who Tei Hayashi had introduced me at cell biology meetings, as with the Sangers and Szent-Gyorgyi and a number of other people who are here, and some only in spirit. And at the end of the course, I had lunch with Gary Morrison. He came to sit down next to me. We're sitting and chatting. And he says, well, you know, do you ever think of coming out to MBL? They have this thing called a STEPS program. I said, you know, no. He said, you should apply. So I did. And I got a STEPS fellowship. Wow. I come out, and who's my host but Shinya? I go there, I'm going to learn microinjection from Shinya. I'm going to work with urchins. Well, the urchins weren't in season. I worked with Sandeller. I never looked back. Fabulous system. Love it. So about a month into my arrival, Shinya said, why don't you give a seminar in my lab group? I do that. And there's one slide that I showed that we had published a 4-panel interference, contrast, and polarized light isolated mitotic apparatus with membranes and without membranes. And I'm going through it and fine. I go to the next slide. He says, wait a minute. You go back one slide. You do that. He said, you've created microtubules. Look, the retardation is stronger in this other preparation. I said, Shinya, the biochemical conditions are not such to allow an assembly of microtubules. He said, well, then how do you explain this? I said, because we've removed the anisotropic lipids that are throughout this whole preparation. And so, retardation being a summation effect, we've now seen that just with the membranes, this is just the microtubules. Without the membranes, we get less retardation. He looked a little puzzled. I said, it's completely consistent with your Wiener's equation experiments and what you published with Hidemi Sato and Gordon Ellis. He paused for a moment, he nodded, and we moved on. And our relationship was never the same. And there was a tighter rapport. Knowing my interest in calcium, he introduced me to Shimomura. Osamu was very kind to provide me Koren and Hamamatsu, and Butch, where are you? Somewhere, yeah. With the photon counting camera. And darned if we weren't able to go ahead and image the prenuclear envelope on calcium signal. first time we had the images printed out with your software, Dan, your software, I got very excited because it was a ring around the cell. I called Shinya, he was at home. I come with the prints. We're sitting now, the lights are off. I'm putting photos out on the windowsill. And Shinya's marveling at this because we finally have this kind of signal. And I said, stop. I made a mistake. I said, I've looped the lookup table. The brightest stuff is appearing black. I've got to go back. Take all the pictures. I went back, I reprinted, reran the experiment, came back. We knew we had calcium microdomains at that point. All of that drove me to where we're at now, which is our understanding of the role of a very complex metabolic network involved in decision-making processes within cells. It's not DNA. And how the different microdomains vote will determine what the physiology is of the cell. And we've tested that. And we're now trying to find the pins to the lock, if you will, that will allow us to know what the decision for this or that or another process. And I say this, and I go into all this, because the work, the science, the teaching, the camaraderie from Shinya was instrumental in this case, and in all the cases you've heard, and many others. One time, I came out here to work with Shinya. This was December. And I arrived, got my room in Swope, and we start our experiments. And the next day, Swope announces that their kitchen is closed. Okay? Well, there were the restaurants up the street. And 2 days later, they all closed. What are we going to do? Well, Sylvia, bless her, made sure that we had a microwave oven and some plates and cups and flatware and lots of ramen noodles and lots of instant oatmeal. And at 3 o'clock, one of the two of us would kind of nudge me, and I'd get up and go to the food buoy and get a couple of sandwiches and come back. That's just part of the humanity that is and was Shinya. And so the only thing that I can do after all of this and sharing this and all that's here is thank all of us for being here, making all of this possible. And then add one last piece, and that's thank you, Shinya.
So, I'm Jerry Rubinow, and I'm one of the first group of employees of the company formerly known as Universal Imaging. Probably everybody here knows this, but Universal Imaging is a company started by Ted and Dr. Inoue to take the software Ted had written for his father's research and make it available to the wider scientific community. So I and the other early employees, like Steve, Dan, and Dion, some of whom are here, had studied computer science, but we didn't know much about biology, let alone microscopy. We would spend summers of those early days of the company in Woods Hole, living in the Inoue's house in town, programming during the days or nights, or end nights. And we spent a lot of time in the lab seeing how Dr. Inoue was using the software and seeing what was working well for him and or not so well, and picking up biology by osmosis and from attending many A2LN courses. Also during his early days, Dr. Inoue held a number of classes just for us programmers in remedial microscopy for dummies. We could see in the lab how smart he was and the full research he was doing with visualizing microtubules and all the other stuff. We knew he was doing cutting-edge research, but I certainly didn't appreciate then the privilege we were given by learning how to properly adjust and use a microscope from the man who pioneered video microscopy. I could see he was a brilliant scientist, but to me, on a personal level, he was Ted's dad. a really warm, infinitely patient individual with a good sense of humor who was fun to spend time with. I have good memories of many lunches sitting on the wooden planks on the seaward side of the Lily pumping station with him and Ted from the food booth. These days, I'm still writing imaging software at what is still essentially the same company as the one I joined in 1980-something, with some of the same people who were with it then, and I would not have it any other way. I have Dr. Inoué to thank, and indirectly, directly and indirectly through Ted for my entire professional career. In that way, and because of who he was on a personal level, he's had a profound effect on my life.